our invitation, and I request you to please make your presentation, sir. Thank you very much.
Thank you, sir, for your nice introduction. First of all, I thank Kakinada chapter for having invited me to share my thoughts about the importance of geotechnical engineering in all civil engineering constructions. When Durga Prasad Garu requested me to deliver a lecture to the field and consulting engineers, I was very happy because I started my career after my PhD as a consultant, and I traveled all over India and handled many projects. A major project being the Prithvi missile project at Balesur, Orissa, wherein my Professor Sridharan was my co-consultant. And after TCE, in that TCE, I have handled many projects. And due to some personal reason, I had to come back to teaching in 1996. But I always have highest regards and respects on the field civil engineers. You are the builders of the nation. And during my tenure, both as a consultant and as an academician, I found that many civil engineers are not bothered about the behavior of the soil below the ground level. All the civil engineers should know that Mother Earth below the ground level is highly confidential. You cannot predict the property using the computer or by mere calculations. You have to feel for the soil, because the soil behavior varies from place to place. For example, if you want to have a construct the multi-story buildings, say the apartments of 20 stories, etc. in Bangalore, the foundation cost is very, very less, because the soil condition is very good. The same type of structure, if you have to construct in Hubli or in Mumbai or in Ahmedabad, you have to spend a lot of money on the foundation. That means to say, the foundation design at one place cannot be taken care in the other places. Soil is a complex material. If you take soil in hand, you will have different sizes of the soil ranging from 0.002 mm to 75 micron and then sand, etc. Whereas the soil has to be tested at every 30 meters interval. Whereas structures, for example, steel, one batch of steel, if you test the sample, it will be same for everything. Soil is not like that. It will have different properties. This I am going to impress upon all the consulting engineers and the field engineers during my lecture today. And also, I am going to share with you the major earthquake that took place in India, that is Bhuj earthquake, wherein the disaster was the natural one, But you can see some surprises if the engineers have taken care. I think we can have minimized the loss. Anyway, natural catastrophe is a catastrophe. Even in the natural catastrophe, civil engineers have the major role. If they have taken care of the soil effect. I will talk about soil behavior, then importance of earthquake engineering, etc. You can see in the figure. All of you must have studied this figure in your basics of soil mechanics. Soil is having three composition: air, water, and solid. But this particular figure is not practically valid. You cannot get a shape of the soil like this. This is the assumed figure. And you must be knowing, using this figure, we have defined 14 definitions and derived 14 interrelationships. Even today that is valid. Therefore, this particular figure, volume and weight relationship, is an amazing figure that you should understand. And of course, this figure, whatever the definition and the interrelationships are derived, is validated in the soil mechanics laboratory, geotechnical laboratory, void ratio, porosity, so many definitions, degree of saturation. So for major one, that is the water content determination. And also the soil is a complex material and it is a three-phase system. If you go and take soil in the hand, you will have different sizes. But if you keep it in the oven and test it, it will be having the water content. And you'll have three amazing the points: air, water, and solid. And there are different types of soils. One is the expansive soil and the other one is the non-expansive soil. Maltic soil, usually the block cotton soil, when it comes in contact with water, it swells. When it dries, it shrinks. Whereas kyanite is a non-expansive soil. Therefore, as a civil engineer, it is our responsibility, whenever you go for any civil engineering constructions, you should know the strength, compressibility, and permeability. These are called as the three engineering properties of the soil. So the strength should be high, compressibility should be less, permeability should be less. You should always go for the calculation of three phases. And behavior of the soil, it is always predictable. People have done a lot of research. During earthquake, what is the type of loading? Under industrial building, what is the type of loading? Under the wheel loads. In case of residential buildings or lightly loaded structures and settlement of soils, these are some of the behavior of the soil. So these are the behavior of the soils. And if you don't take care of the compressibility, the soil is not taken care for the compressibility aspect. If you construct the building without taking care of the settlement aspect and the consolidation aspect, over a period of time, it will overturn like this. Therefore, here the foundations, depending upon the type of soil, you may have to go for shallow foundations or the deep foundations, depending upon the load which is coming on the structure and also the type of soil. So for the economy and safety, the water table effects are important, stability of slopes, land filling, and roots of the trees are also sometimes are very important, which will give the natural stability to the structures. And you can see this figure. Soil below the ground level is totally unpredictable. You may have sand, silt and clay, you may have sand, you may have water table, you may have the rock. We don't know what is the type of soil below the ground level. Hence, the exploration, the investigation of the soil below the ground level is utmost important. Hence, to know the index and engineer properties of soil, types of soil, etc., soil investigation is necessary. This is the reason I am giving this lecture to the field engineers. Then, the back of your mind, those are not, aware of these things. Of course, you are all aware. This combination, I'm just realizing it. If you realize, you may think, what is this soil investigation? What are the information that can be obtained from the soil investigation? Is it required for all types of soils? If yes, why? Generally, these questions will arise once we look at this figure. So the answer is soil investigation is an exploration technique to know the stratification of soil below the ground level, like sand, clay, gravel, etc., and to know the groundwater table, properties of the soil, etc. So we should understand all these things. We can understand all these things by conducting the soil investigation. And the information from soil investigation data, one can predict what is the bearing capacity, that is the strength of the soil, settlement of the soil, type of the foundation adopted. If the soil, suppose, is not suitable, then what are the ground improvement technique one can adopt? We can always plan. So if the soil is not good, you can always modify the property of the soil. And one more question is it required for all types of soils? The answer is yes. Soil investigation is required for all types of soils, whether uh, whether it is a weak soil or the strong soil, the soil engineering structures are constructed. Then if yes, why? Even the soil is good below the ground level, one should go for soil investigation for the economy point of view. If the soil is soft and weak, then the soil investigation is required from the safety point of view. In general, without the knowledge of soil conditions, civil engineering constructions should not be planned from the economy and safety point of view. And methods of soil investigation. It depends on the soil type. So soil boring will be done, the SPT test, field SPT, and SCPT, that is static cone penetration, dynamic cone penetration. For shallow foundations, you can go for plate load test, field vein shear test. If you are going for the deep foundation, you need not have to go for the plate load test. You have to go for the soil boring, SPT, other tests. And you have to collect the soil sample, undisturbed samples, and disturbed samples, and conduct laboratory tests like Atterberg limits, grain size distribution, strength test, permeability, compaction, and consolidation. And the soil investigation report, see, you're all field engineers. Whenever the contractor, soil contractor, submits the soil investigation as a consultant, we should first see the location plan where the major buildings are coming, where the lightly loaded structures, garden, etc. are coming, and the type of structure coming up, and the nature of the soil, and bearing capacity and the settlements, and the recommendations, and the ground improvement techniques if required. These are the important contents of the soil investigation report. If any one of the point is missing, you can straight away reject the soil investigation report. So you should know all these details. And this is the contents of the soil investigation report. I think now you agree with me. Safety is a mandatory thing to the construction industry, as the human being is directly or indirectly involved in the construction activity. Their life is more important compared with the luxury of the construction, according to labor law of Indian construction. Then quality of construction as field engineers, is grouped in two stages, very well. Number one, quality before starting the construction. Most of the consultants will neglect it. Quality before starting the construction. This is directly depends on the prediction expected and accuracy achieved in the soil investigation. Quality during and after construction. This involves the safe design, execution, and maintenance, free construction of the structure with good resale value of the structure. So I'm sharing with you one of the important case history that it was happened in say around 2012 when I was the chairman Department of Civil Engineering UVCE. You can see this, the building. You can see this. This is a 5-story building. This is a 5-story building, and this particular building was being constructed in Sarjapur Road in Bangalore during 2012. And this building was constructed based on the soil investigation report of the adjacent buildings. This is the vacant site. This is the vacant site, and other buildings on all sides of the structure were constructed. And the materials were dumped here in this particular site. Okay. And the contractor of this building did not go for the soil investigation. Instead, he took the investigation report of the adjacent structures here and then used the investigation report and started constructing the building. When he has gone up to third floor, fourth floor, the building started tilting, and then it was demolished 2 days. Okay. And so when the post-mortem studies were done after effect, we found that the soil investigation was not done here, and the contractor has constructed the building on the filled up soil. As a result, the building could not sustain the load. He wanted to uh, economize the soil investigation. See, he in the bargain he lost say around 1 or 2 crores of rupees. See, I will tell you, soil investigation cost about 0.29%. 0.29% of the total construction cost of the structure. This gentleman wanted to save 0.29% of the total construction cost. In the bargain, uh, the building, he lost crores of rupees. So that means to say, for all the civil engineering structures, the soil investigation is required from the safety and economy. Don't bargain with 0.29% and review the soil investigation report with IGS members, Indian Geotechnical Society members. We have 6,000 members all over the country. We'll be very happy to review the report and give you. Sometimes free of cost, mostly is free of cost, and also for me it is free of cost and some reasonable rate. Some people will call this one. We are having the passion towards giving publicity, the importance of the investigation, soil investigation, how it's important for the economy and safety point of view. Don't try to save 0.29% of the total construction cost. Be liberal as far as the soil investigation is concerned. So, for example, for metro in Bangalore, for the third phase, they are spending 5 months' time for the third phase for the soil investigation. So people are realized. But for the ordinary residential building, you should reach the clients, the who are constructing the residential buildings. Even for the ordinary residential buildings, soil investigation is very much required, either for the safety or the economic point of view. I think all of you agree with me. Soil investigation is very much required for the construction of any civil engineering structures. And
Yes, sir, we agree, sir.
general definition of the soil investigation, it is not the book definition. It is the process. It is a process of determining the layers of natural soil deposits that will underlie a proposed structure, and their physical properties is generally referred to as site investigation. We have to understand what is the property of the soil. See, our famous geotechnical engineer of the country, and also the greatest professor of our country, Dr. M.R. Madhav, always in his lecture, I'm his fan also. I used to listen a lot of his lecture. He very beautifully compares, the soil with the human beings. See, if the human beings are not well, we'll go to the doctor. If the soil is not well, the doctor, the geotech consultant will go to the soil. And The accidents, if a road accident takes place, it is an accident, and if human beings dies, the dead body will not be given to the relatives. Postmortem, everything is done, and then it will be given. But if the soil fails due to an accident, so that should not happen, because the failure of the soil can be predicted. If it is a black cotton soil, what is the type of soil for different types of loading, etc. It is a criminal mistake if the building fails due to the soil failure. It is a criminal mistake because the behavior of the soil can be predicted using the soil investigation technique. And the behavior of the soil, as far as the behavior of the soil is concerned, with comparing with human beings, if a human being, if you tell something today, after 10 years, you may U-turn and you may say something else. But if you understand the properties of the soil, it will be same for hundreds of years. If you become a friend of the soil by understanding the properties, you can trust the soil. That is the behavior. So therefore, my dear engineers and students, please understand soil industry. Try to understand the properties, engineering properties, and the physical properties, and the strength, etc., before going for any civil engineering constructions. I think you agree with me. The soil investigation is nothing but the process of determining the layers of natural soil deposits that will underlie a proposed structure and their physical properties is generally referred to as soil investigation. Then purpose. You should also know the purpose of the soil investigation program. See, selection and type and depth of foundation suitable for a given civil engineering structure depends on the soil investigation report. And evaluation of load bearing capacity of the foundation, estimation of the probable settlement, determination of potential foundation problems. For example, expansive soil, collapsible soil, sanitary landfill, etc. Establishment of groundwater table, prediction of lateral earth pressure structures like retaining walls, sheet pile bulkheads, and braced cuts, establishment of construction methods for changing subsoil conditions. And advantages: use the latest techniques, which includes surface and subsurface information of a soil, have complete data of construction site, establish parameters for foundation, cost-effective services, prepares proper site investigation report, best soil treatments. These are the advantages of soil investigation. For example, a typical site investigation for a multi-story building consists of four boreholes to 30 meters with triaxial samples and tested 1.5 meter intervals, or one borehole to 30 meter with 4 cone penetration tests to 30 meter. Okay. The parameters influencing the investigation framework are the geotechnical characteristics of the site. There is a number of layers, whether the subsurface profile consists of the multiple layers, and stratigraphy of layers, then variability of geotechnical properties, various like water table, etc. And then a response to the external loads, and foundation type, characteristics of the investigation, and also scope of the investigation depending on the load, And also the laboratory tests, also it depends on the type of the load coming up, depending on the type of foundation. And measurement errors are inherent. Some errors will be there in the field. And phases of geotechnical investigation, whether the investigation is carried out in a single stage or in two stages, there's a preliminary investigation followed by the detailed investigation. So these are some of the parameters for the investigation framework. I think for this investigation, all of you will agree this conclusion. Uh, Soil investigation is necessary for all types of structures, whether it is residential or otherwise. Approval should be sought from the concerned authorities before the construction of civil engineering construction. That we will take always. We have included that. And third one is geotechnical consultant and forensic geotechnical engineer need to be consulted before construction of any structure. This forensic geotechnical engineering is a new branch of civil engineering wherein some experts will be there. They will predict based on the soil property. So the building will behave like this. Instead of consulting the forensic engineer after the failure, before the construction, if you consult them, they'll give you a correct idea and then the building will be safe. And if you are giving the treatment like stabilization, etc., chemical test analysis and opinion of the soil scientist is very important because the chemicals like presence of sulfate may create some problem to the soil. Whenever you are giving the treatment to the soil, chemical treatments, chemical the chemist, soil chemist opinion is very, very important. Okay, this is about uh, this one about the importance of soil investigation. Before going for earthquake effects, if you have any questions about importance of soil investigation, I'll be able to answer and I'll justify it in the next topic.
Yes, sir. In chat box, there is one question, sir.
Uh,
Shall I read, sir? You will go
read,
through,
read.
sir. So, you told that the plate load test is to be conducted for shallow foundation. If so, we normally doing this test for pile foundation. Deep foundation is wrong.
Pile foundation, plate load test, pile foundation test, pile load test they are doing. See, pile load test is different from the plate load test. See, whenever you are designing a pile, see, pile is having the indeterminacy of nth degree. Below the soil, you don't know. Okay. So, you will design the pile. Okay. And then for the pile, you will do the pile load test. It is not the plate load test. Plate load test is done according to IS 1888, BIS 1888 1962. It is having the specification. You should use the plates having the sizes 300 mm by 300 mm by 25 mm, 450 mm by 450 mm by 25 mm, 600 mm by 600 mm by 25 mm, 750 mm by 750 mm by this one, and it will have a pit. See the size of the pit. Size of the pit is 1:5 times the size of the plate. If you are using 750 mm this one, it is around how much? 3-4 meters or so. Okay, so that is called as the plate load test. So pile load test is similar to the plate load test, but you are using the test pile. The design, the theoretical design will be validated using the pile load test. Pile will be used as, and that will be a lengthy one. Plate load test is having thickness of 25 mm. Pile is having how much length? It's a design length. I have supervised many pile load tests in Mumbai when I was in Tata Consulting Engineers. We used to design the pile, the length of the pile, and that length of the pile we have to test whether our design is correct or not. So that is called as a pile load test. It's not a plate load test. Plate load test will be used only for the shallow foundation. Pile load test is used for the deep foundations. That member can ask me questions and I can come online also if he is not satisfied.
Okay, okay, sir. I satisfied with your answer.
Okay, thank you so much. Are you happy that soil investigation should be conducted for all types of structures?
Yes.
And also, you all become the Indian Geotechnical Society members, or you consult Indian Geotechnical Society members with a soil investigation report, and then take their advice and then go for the construction for the safety and economy purpose. This is my message from the Indian Geotechnical Society. Thank
Yes,
you.
sir. Yes, sir. Dr. Anil Joseph is the now president.
Yes, yes, yes.
Yes, he is my friend.
Okay.
Yes, sir. Thank you, sir. Thank you.
See,
Any
most
other
of the
questions?
time, okay, I'm Prasad. I'm just giving you one suggestion. Okay, can I talk?
Yeah, tell me.
All right. See, what happens is before we start the work, somehow client will conduct one geotechnical investigation reports, and then they establish the geotechnical investigation agency suggests some piles after a depth of about 6 meters, saying that up to 6 meters the soil is not of good capacity and all that. So most of the time, without knowing what type of structure is going to come, geotechnical investigation agency is going to suggest the type of foundations according to the type of soil and all. But the process realistically is the structural engineer should be able to say what is the type of loading, what is the type of foundation he is proposing. Based on that, he has to give a soil investigation map indicating the number of boards required to establish the loads. Now, in a recent project in Bhubaneswar, what we have done is this already established something, and then they have suggested piles. Then we said we are going to have two basements to the structure, above which there will be 10 stories. These two basements, 10 stories, is hardly creating a bearing capacity of only about 30 to 35 tons per square meter. And we said piles are not required. Then we have again requested the geotechnical investigation agency, forget about your piles. Please suggest the raft for raft foundation. What is the bearing capacity that can be sought at a depth of about 7 meters, where we are going to lay the foundation. Okay, so the structure engineer should be able to say that and then re-establish the safe bearing capacities from the geotechnical investigation agency. Okay, then we also give the footprint. The footprint of the building is going to come like this at the 7 meter depth. Then you better estimate the bearing capacities, the bearing pressures which we are getting are like this, then re-establish. Then they will be able to give it once again, the revised bearing capacities based on settlement of the raft foundation and all. It's just for information to all the structural consultants. Thank you.
I want to react. Sorry.
Thank
Shall
you,
I
sir.
react?
Very practical.
No. Shall I react to this?
Yes, sir. Yes, sir.
Please, sir.
May I know your background, sir?
Sir, I am a structural consultant.
See, as a structural consultant, you have accept. I am according to me, you are accepting the defeat and going for win-win situation. If I were you, when I was in the TCE in 1994, similar type of things came to us. They have done some soil investigation, asked us to quote, and we quoted, and we got the job. And then in the quotation, we clearly mentioned we have to conduct the soil investigation fresh. You have to conduct the soil investigation fresh. For example, see, I'm an academician also. I'll be called for some interviews in KPSC and Indian Engineering Service also. I conducted interviews for UPSC. I was asking simple questions to the budding IES aspirants. What are the two important aspects as a civil engineer one should do? Many of them are not able to answer. Number one is the survey of the area. That is the map. You should have the map. You should have a clear map where the I mentioned in my presentation also, where the heavily loaded structure is coming, where the garden is coming. Suppose it is an industrial building, where the heavily loaded structure is coming, where the garden, where the kitchen, where the apartment or the quarters. See, depending on that, based on that plan, the geotechnical consultant will give you the geotechnical investigation. If the machine is coming, we are going to propose the black vibration test, because the natural frequency of the system, of the soil foundation system, and the operating frequency of the system, if it is between 0.5 to 1.5, resonance will occur and the building will collapse. So it should be less than 1.5 or more than 1.5. So depending on the structure, the geotechnical consultant will give the investigation plan. Then you have to conduct a geotechnical investigation. Based on that, you have to do the structural design. In your case, if I am not wrong, what you did is, they are telling 6 meters something, you are yielding to them without understanding the investigation report, without consulting the geotech consultant. If you have, you should have first, if they give the geotechnical investigation report, give it to the consultant. Nearby college or the IGS members are there in your locality, and then they will give you the idea, and then go for the investigation again. Educate them, because if you are going for the raft foundation throughout, instead of going for the pile foundation, if it is a good soil, if there is no differential settlement, then it is a foundation cost, it will escalate like anything. Then as civil engineers, we should suggest them, you go for the cheaper method, cheap and best. Raft will be, sometime it will be costlier, unless there is a differential settlement problem is there. Raft foundation will be used wherever there is, we want to expect a, the uniform settlement. Okay, I think.
Okay, let me tell. No, you are going other side. Let me clarify to you that basically the structure is meant for a residential apartment. In a residential apartment, what happens is
how many stories?
The structure is basically meant for a residential apartment.
How many stories, sir?
Yes, this is about 2 basements and 10 stories above.
10 stories.
Now, what happens in a residential apartment
only
is
one
that.
pillar?
Now, let me complete. What happens in a residential apartment is that the columns are shear walls, what we call, they're all pretty closely spaced. They are spaced at a distance of, let us say, 4 to 5 meters. Okay. And then we'll have the room dimensions, let us say about 3.5 meters by 4.5 meters or 5 meters, like that. And what happens? The columns are pretty closer, enclosing the room space. When they are pretty closer, then raft is an ideal situation, not
Okay,
pile
okay.
is the
Sorry
situation.
for the interruption. Raft is the ideal condition for the
Correct.
apartment. That is not my
Is
question, sir.
in the case of a
My question
in the
is,
case of a IT building,
my question is,
I understand what you are telling,
the
but
soil
compare it to the
investigation
piles.
should have done under your instructions. You should not be instructed by the client. This is the soil investigation. That is my point.
No, the point is well taken. What I am saying is
And
the
for
client has,
apartment, okay, sir, you can go for raft. Yeah, I am also staying in an apartment
all right, all right.
where because differential settlement, otherwise you will go for the pile foundation. There'll be differential settlement problem will be there. Now, what my point is, we should not be yielded by the clients. This is my investigation. You have to do it. Then you have to tell them that it should be certified by a qualified geotechnical engineer. Then only accept, sir. It is our request from the geotechnical side. Please
Exactly.
accept the
What
soil
we also do
investigation
is,
report.
exactly, most of the time, whenever these reports are coming in like that, they are not that much experienced, the geotechnical agencies. Then we usually use Professor Madhav from the ex-IIT Kanpur professor, okay, and as well as Professor
The client
V.S.
to get it
Raju,
certified.
okay, to validate the geotechnical reports, and then
That
avoid
is
piles,
our
go for raft, something like that, depending upon the
it
bearing
is the
capacity that
response.
we are
If the
going to
client
get.
has soil investigation, it is his responsibility to get it certified. Why we should get certified? Get it certified.
That's all right.
The client has to get
My
it certified.
simple suggestion to anyone structural engineer is that they should read the geotechnical report thoroughly and then understand it, and if necessary, challenge it, or again take the opinion of a specialist geotechnical professor or consultant who is in the field, to such that foundation cost is optimized, not to waste much money into the foundation.
Right.
Okay. Thank you very much. Nice talking to you.
Also, one more request is from the IGS. I'm an IGS National Executive Committee member. Please do not accept any investigation report which is not certified by the geotech consultant. Nowadays, every Tom, Dick, and Harry is doing the soil investigation. They are writing in the chamber and submitting the report. Be aware of it. Be aware of
Exactly.
it.
What
Be aware.
what I am insisting
They are all
is here there is
Deshaprohis. They are all
geotechnical
traitors.
report. Now let me clarify one more point. We are insisting that geotechnical report should be certified by a MTech soil mechanics guy, not any other guys.
And
If
also
there is
the
a
investigation
geotechnical
photo
agency,
should be there. Photo.
sorry.
For having
Okay.
conducted the investigation.
Yes, I understand
That's
the
right.
offshoot guys have come up. Okay, that we are not encouraging at all. We are insisting that MTech soil mechanics guy only have to sign the report, geotechnical recommendation reports and all that.
Very
Otherwise, we are
nice.
not accepting it.
So kind of you. Thank you very
Everyone
much.
should do the same.
Thank
Yeah?
you. Thank you.
Okay, sir.
I'm very happy.
Thank you. Nice talking to you, sir. Bye.
Yes, sir. Thank you.
As engineer C. Anya Prasad from Hyderabad, sir. He is a famous consultant and structural engineer, very much famous in precast engineering, sir. And he is the
Very
chairman
nice.
of PSI.
Very nice. Well learned man.
Yes, sir. One question is posted by Ambarish, sir. He is recommended the formula Q net is equal to 0.088 into CWN SA in ton per meter square. How relevant is how relevant is the formula for calculating for SPC calculation of raft foundation, sir? How relevant is the formula for SBC calculation of for RAP foundation, developed by Tech Hassan.
See, RAP Foundation, Indian BIS code is there. The design itself. See, why you refer foreign books? Or Indians have developed it. Foreign soil is different from here. They must have done it for the foreign soil. I always bat for Indian conditions and Indian code. Follow the Indian code. For example, SPT test, they will say 10 mm height of fall and the weight is around 63 kgs. Indians will say 75 centimeters height of fall, 65 kgs height of rammer. And seating blows, etc. they specify. So let us follow. We are doing design and the construction in India. Let us follow only Indian codes. I don't believe in foreign codes. Only for the reference sake, for the research, you can do it. For construction, Indian constructions, let us follow Indian code only, BIS code. Okay. Any other
Please continue. Please continue, sir. Please continue.
Huh?
Sir, please continue for next, sir.
Okay, no other questions?
Yes, sir.
Okay.
Quick considerations.
So I'm very happy that it is well received. And based on this, I'm going to show one more case history wherein the engineers, if the engineers are aware of the importance of soil investigation report, even the natural catastrophe will minimize the loss. Natural catastrophe we cannot avoid. So Bhuj earthquake is the major earthquake. It took place in India on January 26th, 2001, around 8:40, when Indian flag was being hoisted on the Republic Day by our late Prime Minister Atal Bihari Vajpayee ji. This earthquake took place in Bhuj, Gujarat. As a result, 144,000 people died. So many loss of life, property, etc. We always feel as civil engineers, even the natural disasters we can minimize. This is one of the examples I am going to share with you, and I'll put a question to you to decide. Of course, the earthquakes, there are in the Richter scale, you can see many earthquakes right from 1960, ranging from 9.5, 9.1. So many earthquakes took place in the world, but the major earthquake in India was the Bhuj earthquake. It took place in 2001. You can see you may just you can see earthquake takes place, what will happen. You can see an earthquake cannot be predicted. In India, we have divided the earthquake zone into zone 1, zone 2, zone 3, zone 4, zone 5, like that. See, it is, the focus will be below the ground level, about 100 of kilometers below the ground level. And if you project it to the ground level, it is called as the epicenter. And then epicentral distance. So epicenter is Bhuj. Now the place of interest is Ahmedabad. It is around 200 kilometers. That is called as the epicentral distance. I'm going to show some of the things in Ahmedabad, which is having the epicentral distance of 200 kilometers. And the epicenter is the Bhuj. Okay, the earthquake may be caused by volcanic eruption or by a strained building process inside the earth mass. It is totally unpredictable. So it is the vibration of the earth's surface by waves originating from a source of disturbance in the earth mass. You can see here that is called the focus. You can see the focus, epicenter, wave fronts, the faults. So this is the epicenter. Okay, now the earthquake engineering branch is there only in 2 institutes in the whole country. One is in IIT Roorkee and other is in UVCE, Bangalore University. In only 2 places we have earthquake engineering branch. See, compared to all disciplines of civil engineering, earthquake, particularly geotechnical earthquake engineering, is quite youngest. While the damaging effects of earthquakes have been known for centuries, the strong contributions of soils to the magnitude and pattern of earthquake damage was not widely appreciated until recently. Following the damaging earthquakes in 1964 in Niigata, Japan, and spurred by the growth of the nuclear power industry in 1960s, 70s, field of geotechnical earthquake has grown rapidly. And it has got many researchers over the 30, 40, 60 years. And so of course, the study of earthquake is back to many centuries. Today, hundreds and millions of people throughout the world live with a significant risk of their lives and the property due to the earthquakes. Billions of dollars of public infrastructures are continuously at risk of earthquake damage. And the earthquakes have occurred millions of years ago. And then coming to our discussion, geotechnical aspects of the Gujarat earthquake, that is the Bhuj earthquake. I'm going to tell you briefly about the earthquake, ground movement and liquefaction, foundation, highways and railways, embankments, port facilities, bridges, locals experience, codal provisions in India, concluding remarks. You can see February 26th, 26th January, Republic Day of India took place at 8:46. Epicenter, western part of Gujarat, has shown what is epicenter. Ran of Kutch, 20 kilometers. Latitude and longitude is given. Magnitude is around 7.7. Focal depth below the epicenter, it is 18.2 kilometers. Caused severe social, economical, and financial damage. And shaking. See, earthquake took place. This earthquake for over only 90 seconds, but after effect is 150 seconds. You can see the Bhuj where the earthquake took place. You see 16,480 people confirmed dead, 144,000 injured, 200,000 homeless, so many destroyed, 18,000 cattle dead. Damage estimates about $1.3 billion. This is a natural catastrophe. And now, power and water supply disrupted. Telecom link with Kutch snapped. Surajbari Bridge, the Kutch region, damage, irrigation dams destroyed. One of the worst to have occurred in the country during the last 180 years, for which seismological records available. First recorded earthquake also in Kutch in 1819. Latur earthquake in 1993, which killed 10,000 people. It recorded only 6.3 on the Richter scale. Seismic history, it is the seismic history of the town of Kutch. See the Gujarat earthquake, the railway tracks, buildings, Gandhi statue, all these things. So this is the after effect of the earthquake, about 90 seconds. But see, the press people, they have quoted all the press people, reports in newspapers and magazines. They have mentioned that it is the Republic Day killer, okay. But they gave a damaging statement. Engineers killed people, not the earthquake. So this triggered us to analyze this particular earthquake data, or just to show it to the engineers from the geotechnical point of view. We are trying to present why they have told like that, the press people. They are non-engineering people, but they are directly blaming the engineers. It is a natural catastrophe. How the engineers are responsible. So that's what we are going to discuss now. And you can see the ground breaks happens here. It is actually, it happened due to the liquefaction. I will tell you the liquefaction of soil. Liquefaction of soil is nothing but when the total effective pressure is equal to 0. You know, you must have studied the total pressure when a load is transferred from the superstructure to the soil, to the foundation, then to the soil. There will be resistance from the soil. Soil will have, the solid as well as the water. Water is having its own property. Water will have always to maintain the horizontal level, and depth of the water will not be known to you. For example, in the swimming pool, if you go to a swimming pool, you will not be knowing the depth. Unless they put it is 0.5 meter, 1 meter, 2 meter like that. So the depth will not be known. And then water cannot be compressed. Whereas air can be compressed. That is the reason why this transportation, air can be compressed to the vehicle, and then vehicle can move. Air can be compressed. If you take water and compress, it will not be compressed. Water is so adamant. If you apply load, the load is transferred from the superstructure to the of the building to the foundation, then to the soil. The water will resist individually. That is called as the pore water pressure. And soil will resist individually. That is called as effective pressure. Effective pressure is called as the sigma dash plus U is equal to total pressure. So effective pressure sigma dash is equal to total pressure minus U. So this is called as the effective pressure. Effective pressure is nothing but the resistance of the soil alone. The pore water pressure is the pressure resisted by the water alone. So this total effective pressure, when it becomes zero, then it is called as the liquefaction. When the dynamic load happens, even in the machine foundation design, it's very important, especially in the sandy soil. In the sandy soil, the vibration occurs, the total effective pressure sigma dash is equal to zero because the pore water pressure will be more than the total pressure. Sigma dash is equal to sigma minus U. The total pressure, the effective pressure is equal to zero because the pore water pressure will be more due to the vibration. During earthquake, what will happen is the heavy dynamic load will pushes the water. If it is a soil, the sand will flow like liquid. That is called as the liquefaction of the soil. That type of effect happened here. You can see the soil, the sand is flowing like a liquid. It is a liquefaction. The important feature of this earthquake, as per the geologist, is the absence of large length faults on the ground. Geologists predict fault slip movement and also liquefaction. You can see the liquefaction. So people may not have predicted the heavy dynamic load. Therefore, they have taken the sand very lightly. They have not taken care of the liquefaction effect. Therefore, the liquefaction took place. So when the total pressure below the foundation becomes zero, what will happen? Building definitely collapse. Railway tracks will become, unparalleled. Okay. Sand blows varied with size and size reduced with increase in distance from epicenter. You can see the liquefaction failures. And, this is relation between this one. And also the rock slides from moderately sloping hills. And lateral spread, it is also due to liquefaction. Lateral spread. See, when the foundations were analyzed, majority of the buildings in the Kutch regions were founded on shallow foundation. Top 300 to 600 mm are made in blackwater soil. Only top 300 to 600. Better quality construction comprises of coarse stone masonry. Poor quality construction. RCC structures are also founded on shallow isolated footings. Collapsed buildings in Rapar you can see. Masonry with poor or no mortar joints. Heavy tile roof. Most of the buildings are built without engineered design. You can see most of the buildings were built without engineered design. This should be taken a very important point. Foundation consists of shallow wall footings. Where earthquake force, just small earthquake force was sufficient to uproot the buildings. You can see here the apartments failed. Multi-storied buildings. Akashdeep apartment in Ahmedabad, which is 200 kilometers from the epicenter. Home apartment, Ahmedabad. The common found in all these things are all are situated in Ahmedabad, more than 100 in number, perhaps on soft alluvium, and all are RC 4 to 5 and even 10 storage buildings. All are relatively recently built. All of them suffered serious damage during the Bhuj earthquake, but survived other natural calamities such as heavy rain. Over 250 kilometers away from the epicenter, not 200, 250 kilometers away from the Ahmedabad, it happened. Then now the question arises to your mind, Is it a bad construction quality? Not following the building bylaws of the city property? Improper design? Not considering the earthquake? We have a zonal earthquake zonal condition, zone 3. Stress on economy, poor material standards, liquefaction of ground. You have seen the liquefaction also, or something more. So these are the questions we should ask forever. If you go on answer these questions, again, press people will take it as a chance. It does not leak it to press. That as engineers, we have to question ourselves. All these questions, very important questions. Fortunately, press people are not knowing these questions at that time. And in soft aluminum amplification of the ground motion was as high as 19.46. And the estimated natural frequency of the ground, the natural frequency of the multi-story structures and the predominated frequency of the earthquake matched. That is operating frequency and the natural frequency is equal to 1. When it is equal to 1 or between 0.5 to 1.5, the resonance occurs and building will collapse. That's what happened there. So the amplification, this natural frequency, they should have calculated as per the zonal 3 provision of the Indian code. And site amplification and near resonance condition are two major causes of the failure. Then more rational codal provisions are necessary. They are not taken care of the code. Micro-resonation of the important cities, installations of more seismographs. The seismographs installation nowadays they are doing it. It was not there in 2001. You can see the damages. The national highways, you know, there are over 5,400 kilometer roads in Kutch districts are damaged, 100 kilometer length affected. Damage include longitudinal crack, transverse crack, slope failure, drainage structures, etc. Some railway bridges were damaged. Bridge approaches settled, lateral spreading, railway line near Navalaki port experience settlement of order of 3 to 4. You can see the important point. No damage to runway in Kutch earthquake. See, whenever the airport is being constructed, sanction will not be given unless all the soil testing is completed. They are happy with that. They have done perfect soil investigation. Nothing has happened to Bhuj earthquake. Port failed. Dams failed. Buildings failed. Bhuj earthquake did not damage the Bhuj airport. So it's a natural disaster. It will not have the partiality. The natural disaster was resisted by our engineers. Hats off to them. Whereas other one, they are non-engineering or not aware of the soil conditions. They are not aware of the resonance conditions. So here they are taken care of everything. Resonance condition will be taken care. Block vibration test, all dynamic tests will be conducted in the airport. So nothing was happened to the airport. So this is one of the things you can answer. The questions I asked. I don't want to answer this. I leave it to your discretion. I'm going only the answers. So highways, you can see here the railways. See, railways failed. Here, Navalaki port, it is failed. You can see all the dams are failed, or the classical geotechnical damage. You know what is classical geotechnical damage? These are all available in our journals. Our researchers are already reported it. Our geotechnical experts will be knowing this. For a particular type of soil, this type for load and this one, this is the type of damage. All damages are, most of the damages are classical geotechnical damage. It is not the new damage. We could have predicted, the forensic engineer would have predicted this. Again, it gives the importance why the geotechnical expert is very important in any civil engineering structures. And we would have saved many of the dams out of 20 medium and 165 minor dams in Kutch. Then 144 medium and 17 minor dams in Saurashtra. See, Raita Dam on these locations, you can have a look. Then Raita Dam is, Ratia Dam is situated around 5 kilometers northwest of Bhuj. Small irrigation. Southern dam suffered severe damage, almost dry, and water was present, dead storage, basalic outcrops, canal regulation. So it was almost dry. That is one of the case thing. You can see the Suratbari bridge. It's failed. You can see the note below. The new highway bridge under construction. It's a new highway bridge under construction. View of the existing highway bridge near Surajbari. The bridge sustained heavy damage during the Bhuj earthquake. Can you see the new bridge and the old bridge comparison? And picture showing the large lateral and vertical displacement of two spans. Picture showing the bonding between two adjacent bridge spans. And the extensive lateral spreading, again liquefaction only, sandy area. Then photograph showing the Dramata bridge. There was no apparent distress to the bridge superstructure. You can see this is very interesting. Picture showing a damaged stone masonry arch bridge. The bridge was built in 1912. Several stone masonry bridges and buildings have been destroyed in this quake. Temporary side supports are being erected in to retain the ballast and open the traffic. The 1912 constructed bridge. Photograph showing the damage in another masonry arch bridge. So one of these bridges were also built in 1912. Not much damage to this. It can be repaired. The bridges which are constructed in 1912. Railway and bridges. Listen to the railway and highway bridge. The highway bridge also failed. Here also last point you can see there are signs of liquefaction and lateral spreading at this location. Total effective pressure below the ground level is 0 means gone. Okay, the soil flow like a water. On a water foundation will not stand, it will fail. Liquefaction happened here. Here also the failures. And a vertical crack, the entire height of the pier you can see, recently constructed. Severe damages. Konda port also failed. See here, 6-story port and customs office. in the failure condition. Again, in our report, lateral spread liquefaction. Whenever the sandy area is there and some machines vibrations are expected, or it is an earthquake prone area, we should take care of the controlling the lateral spread, that is the liquefaction of the sand. If it is a the having a soil, only the clay area, liquefaction will not take place in clay area. Liquefaction takes place only in the sandy area. See again, ground cracks. So both the port suffered damages. Damage in Kandla port included failure of pile foundation. Damage in Navlaki port consists of lateral movement of walls, ground movement, ground break, etc. So codal provisions in India. Codal provisions in earthquake engineering in India exist since 1950s. But only 3 or 4 modifications are incorporated. For example, RCC code, 456 code. When I was studying B in 1981, now it has a lot of changes and lot of revisions. Whereas the earthquake code doesn't have the revision. There is some problem in the hello. Hello.
Yes, sir.
There is some problem in the presentation.
Yes, sir. Widescreen, sir. Only widescreen we are seeing.
You have not seen the picture?
No, sir. No, sir. It is completely widescreen.
Since how much? How much time?
Just only, sir. This slide and previous.
Can you please share that?
Okay.
Can you please share after that
Yes,
point?
sir. 1 minute, sir.
Only one slide missing, last slide.
Slide number, sir.
Come to last one.
Last one before thanks, sir.
Huh?
Last
Kind
but
of
one, sir.
Port.
1 minute, sir.
Sir, the codal provision slide was lastly displayed.
Yeah, codal provision. Come to slow codal provision.
Is my
Yes,
screen
sir.
visible, sir?
That is after that nothing.
Codal provision in India.
Please fix it.
Please. No, go up. Go up.
1 minute, sir. 1 minute. Yes, sir. This one, sir.
No, go up. Go up. Here. Go next. Come down.
Yes, sir. Yes. Next, sir.
No, you're going up. Come down.
Yeah, okay, sir. This is the codal provisions in India, sir.
Yeah. If
Next
you
slide.
please enlarge it.
Enlarge, okay.
Codal provision. Go.
1 minute, sir. 1 minute. Yes, sir. Is it okay, sir?
Yeah, same thing.
Yeah.
See, codes in India for masonry and other things, we have a lot of revisions. Whereas for the earthquake, up to 2001, we had only 3 or 4 modifications. That is one of the reason, the codes are not available. And design recommendations in that particular region was based on the strength criteria, not on the permissible deformation criteria. So in soil, we should take care of the deformation criteria also, consolidation and compressibility criteria. Okay, next one. Next slide, please. This is a very important local report. Go to local report. See, you can, it's a very interesting one. You can have a look. Large column of water up to 6 meters for over 30 minutes beyond earthquake was as T was reported. Normally, saline groundwater turned sweet. These are the two local observations. The same report was made about 1819 earthquake also in the same region. And the Chang Dam was blasted and breaching was sudden. This was the very interesting local report. Next. So in general, we can say that large lengthy faults are not visible at the ground surface. Geotechnical failures did not deviate from the routine types. You would have predicted and designed geotechnical failures. And liquefaction was reported mainly by formation of craters, sand blows, and lateral spreading. So this is one of the major causes that also would have taken care. Flow failures and landslides were minimal. Most dramatic geotechnical failure was the damage to nearly all our dams in the region. Subsoil failure was the major cause. You can see last point, subsoil failure. That means soil investigation was not done properly there. People have not understood what is soil investigation at the time. That is one of the major causes. Next. All dams were almost empty. We are lucky actually. Following 2 seasons of drought. Otherwise, damage would have been more severe. And the Surajbari Highway Bridge was the only major bridge to suffer. A few and small bridges failed. The few old and small bridges. Most buildings in Kutch were built on shallow foundations. Buildings along with foundations were uprooted by the mere earthquake force because of closeness to epicenter. Next. Next one. Next slide, please. The IS course I told is still being improved. The design of embankments and dams is still based on present day understanding of design from the consideration of allowable settlement needs to be practiced. This is one of the message to our practicing engineers. Settlement criteria should be taken care in all the designs. It is very important. Whenever you come across with the soil, microzonation of important cities, particularly in seismically active zone, is useful. In general, Butch earthquake was an eye-opener to bureaucrats, politicians, general public, technologists, and researchers in India. Engineered structures fared better. I think you agree with me in Butch earthquake also. Even a small residential building should be constructed with the plan of the engineer. Then they can save around 50% of the construction cost. That we should give publicity to the public. Engineered structures fared better, suggesting the importance of adopting strict seismic design in the areas prone to earthquake. Next. This is one of the questions posed by the press people why elevator survived and the rest collapsed around it. This is because other buildings also would have been survived if they have conducted the cooperation test and if they have maintained the natural frequency or the resonance value below 0.5 or more than 1.5. This building, this pillar by chance must have got the resonance condition below 0.5 or above 0.5, above 1.5. Resonance is nothing but the ratio of the operating frequency to the natural frequency. The natural frequency is nothing but the frequency of the soil foundation system. Natural frequency of the soil foundation system can be determined using black vibration test and other techniques. So they could have conducted the test. They have not done it even though it's a earthquake prone area. In the earthquake prone area, and whenever you are designing a machine foundation, you have to find out what is the natural frequency of the soil foundation system before going for any machine foundation. Next. And now I told you to conclude. Now you can tell, you can answer to yourself about the press people question. Does the earthquake or do the engineers kill people? I don't want to answer this. A well-engineered structure behave better. Is it necessary to build all structures at all locations to be earthquake resistant? If so, what magnitude of earthquake should they counter? So these are the questions we have to conclude and we have to ask ourselves throughout our life. Next. Next one. And also, you're all field engineers. No, go to that. Next name, previous one. Previous one, huh? See, all of you are field engineers, honorable field engineers. I would like to bring it to your kind notice. The interdisciplinary link. See, as civil engineers, always we feel that structural engineers are only civil engineers and we are only supporting engineers. Yes, we agree.
ಎಲ್ಲ ಓಕೆ ಎಲ್ಲರೂ ಮೆಡಿಕಲ್ ಕೊಡು ಒಂದು ನಿಮಿಷ అటుకదరా చేసు ఎలాగ కొత్తవా
తెచ్చుకున్నావు అక్కడ చదువుతుంటారు
Hope problem with speaker's internet. Please wait 1 minute.
Good afternoon, sir. I am T. Naidu, assistant professor in Nadempalli Satyanarayana Raju
One
Institute of
minute, sir.
Technology.
Actually, speaker has some internet issue. Please wait 1 minute, sir.
Okay,
Right.
thank you, sir.
Okay.
Hello, am I audible now?
Yes, sir. Yes, sir. Audible, sir.
Okay. Double sound is coming.
Sir, hope you entered in login with another, sir. Another. Please mute
Yeah.
one. Mute one, sir.
Huh?
Yes, sir. Yes, sir.
Am I audible now?
Yes, sir. Yes, sir. Clear, sir.
Okay. So go to the previous slide.
Hello.
Go to the previous slide.
Okay.
Hello.
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 Sir, is it okay, sir?
Previous one.
Sir,
Previous
not
one.
hearing properly, sir.
Durga Prasad, I am audible.
Sir, you are audible, sir. You are audible, sir.
Hello.
Now you are audible, sir.
Hello.
Hello.
Sir, you
Am
are
I
audible,
audible?
sir. You are audible, sir. You continue, sir.
Huh?
You are audible, sir.
Okay. Now you can see this slide. The geology, seismology, earthquake geotechnical engineering, structural engineering, and civil engineering. See, they will give, geologists will give earth structure, tectonics, etc. Seismologist will give seismic event. The earthquake geotechnical engineering will give the ground hazards, response, etc. And then structural engineering will give soil structure interaction, response of structures, and civil engineers in general, performance modeling and earthquake resistant design. Next slide. See here, aspects of earthquake geotechnical engineering. It is nothing but dynamic loading from anticipated earthquake, field laboratory test to determine the modulus, damping characteristics, estimation of liquefaction resistance, estimation of settlement due to dynamics, analysis of bearing capacity due to dynamics, other earthquake effects, site improvement, building code provisions, etc. Next. I think you agree with this figure.
Connection
Why should not structural engineers, geotechnical engineers, geologists, other engineers join hands? See, structural engineers, above the ground level you will design. Geotechnical engineers, below the ground level they will give you the properties. And geologists will give the general property of the soil, and it will help us in designing the earthquake resistant structures. Next. Last one. Okay. It is, you can see this, it is impossible to stop or predict earthquake. As engineers, let us all unite and move forward
and reduce calamities due to natural or man-made hazards. Thank you. Thank you. So any questions you can ask now.
Durga Prasad, I am Srikanth from Bangalore.
Yes, 1 minute, sir. Thank you, sir. Thank you very much for your valuable presentation. Detailed explanation of what is soil investigation, why it is needed. I mean, importance of the geotechnical investigation, forensic engineering, and a detailed explanation of Bhuj earthquake happened in 2001 and the various damages happened to the infrastructure. It's a good thing that runway not damaged since very geotechnical investigation done in a good manner. Now I request the participants to raise your questions. Srikanth Channel, sir.
Okay. Thank you, Durga Prasad.
Yes, sir.
See, we have lot of experiences that we gained from the failure of structures at Bhuj of 2001 earthquake, as we have already heard enough from that. However, the lessons that we have learned from this particular earthquake, so speaker has mentioned that it is an eye opener. I don't think we have opened our eyes till now, because the Gujarat, the disaster was happened, and the main cause of the disaster was non-involvement of the civil engineers in the buildings specifically. When he told so many buildings have collapsed, and the expert report was that the buildings which have totally come down was due to the non-involvement of the experts. And most of the high-rise buildings were having some damage, but not to the state of collapse. And this was the result of, earthquake. This Gujarat Professional Civil Engineers Bill came into existence. So that is point number one. Our NBC, if you look at it, it doesn't make this earthquake design or this involvement of the geotechnical engineer, even the structural engineer, mandatory for the low-rise buildings. The low-rise buildings component in the overall buildings is 95 to 98%. That is G+4 and below. Whereas high-rise buildings, it is only 2%. If you go to the statistics of Ministry of Statistics, you will come to know this. However, our codes very, very specific and stringent for the high-rise, whereas low-rise buildings which are G+4 and below have been totally neglected. And recently, I think in your Kakinada Center seminar only, Dr. Rao mentioned that Turkey earthquake, the experience that low rise buildings have suffered a lot, and that particular earthquake has been more effective on the low rise buildings only. When this was the situation, why our people are not unitedly, thinking about this? Majority of the buildings are getting suffered in all kinds of natural disasters, and involvement of the engineers is very, very essential. And mandatory involvements are not there in the NBC. And we are not proactively participating even in the NBC also. All these things should be brought in NBC, number one. Number two, we should have, the regulation and the professional act in place. So this is what is my point. Unless and until every building has got the technical touch, expertise touch, things are not going to improve. And this is my opinion, which we have not yet, gained the experience. According to me, if such Bhuj earthquake kind of a thing happens in every state only, then only we will start, enacting the bill. So that unfortunate state shouldn't have, should not come in future. So in that direction, we should all, sit together, think properly, and bring a good, act or professional regulation in place for applicable to all the states. Thank you.
Can I respond?
Yes, sir. Yes, sir.
Hello, can I respond?
Sure, sir. Yes, sir.
Uh, Thank you, sir. Srikanth Chennal, sir, very nicely said. But in Karnataka is the first state to bring that bill. It is passed in Karnataka.
No, sir, second state after Gujarat.
Andhra first,
No, no, Gujarat.
Gujarat first, okay.
That is
Actually,
because of the Bhuj earthquake only it came into existence, sir.
actually what happened is, nowadays, 2001 onwards, the field engineers should have gone to all engineering colleges and given some lectures and educate our youngsters. Nowadays, what happened is, even in Andhra Pradesh, also, many engineering colleges are starting without a basic course civil engineering. Civil engineering is mother of all engineering. These engineering colleges should not be given permission. The Association of Civil Engineers, it is your fundamental duty. You object it to write to the ACTA. ACTA chairman is a civil engineer, Professor Sitaram. You write a letter to the ACTA stating that without the civil engineering branch, basic branch, the engineering college should not be opened. Engineering colleges are opened as a business. They are doing business, and the civil engineering students are discouraged. We have to encourage the civil engineering students to take up this, because in the years to come, civil will have more scope. Lot of projects are coming up, and without quality engineers, what you people will do? I think ACC is the right time for the ACC to write to the government and also ACTE to state that no engineering college should be allowed to open if the civil engineering branch is not there, and civil engineering branch should not be closed. And they have to attract the civil engineers.
Ramesh garu, sorry to interrupt. I think we are deviating from the main topic. Let
No,
us
this
leave
is the
that.
thing, sir. Otherwise,
No, I can
this
understand.
type of
I can
collapse will
understand.
happen.
I can understand.
The
It's a big
buildings will
topic.
fail.
Yeah, it is a big topic. Okay.
Sir, it
No,
is
that is
market.
only one point I am appealing. That's all. Only one
Sir.
point. No, I am not extending this. Only one point. No engineering colleges should be permitted without civil engineering branch. And who will
Sir, it is all.
construct the bridges,
All right.
etc.?
All right,
Computer
your point
engineers
is
will do
taken.
that.
Yeah, Dr.
So
Ramesh
this
garu,
is
your
my
point is
submission.
taken.
Anyway, this is my submission. Sorry.
All right. I agree. All of us agree. All of us agree on that particular point. Okay. Now coming back to what the other member have said just now is that we are serious about earthquake engineering design after 5-story structures and all. Most of the rules state that up to 3 stories, the design need not be submitted, or something like that is there in all the municipalities, which is not correct as the previous member have said. I think we have to bring it now. The entire India is an earthquake bed, and the code is also going to change from Zone 2 to 5 to even Zone 7. They are coming up with the revision of codes and all that. Okay, and then they are adding more zones into the increased zone activity is what we are looking at. Already the draft code has come for the earthquake and people are taking it. And then we have to do in such a way now that even a one-story building should be earthquake design should be made and then only submitted to the municipality or the statutory authority for design. Even for 1-story, 2-story, 3-story, we should not leave these. Okay. Now, if we look at BMTPC have brought some, with the help of IIT Kanpur, have brought some guidelines for how load-bearing structures can also be provided some bands of RCC element to make it more earthquake resistant structures. Not only RCC framing structures, but the load bearing structures also. People have to take these particular guidance and then design the structures. Okay, we all know that in Bhuj, it's not properly engineered structures which have collapsed predominantly. One example that you have rightly shown is why the lift wall is alone there while the other structure have fallen down on the other side. Basically, when we talk about diaphragm action, all the slab reinforcement should be linked to the lift core. When the slab reinforcement is not linked to the lift core, then all the rest of the columns and slab have fallen down and the lift is standing erect because it has more stiffness, it has more resistance. Okay. Predominantly, the lift cores are the main thing which will act as a wonderful shear wall elements, and we should connect the slab elements to that. So back when at the time of Booch, the engineers they do not have much of this knowledge. They have not connected the slab reinforcement to that, and with the result, all the columns and all have fallen down, and the lift core alone is standing. So we are trying to give this particular knowledge to the people. Then, okay, this is the basis of any this thing that lift core and stair cores are the main shear walls where the code talks about. They will be standing as a cantilever earthquake elements, which will give more stiffness, more resistance than the other walls and all. So that emphasis we are giving to all the structural engineers through various forums. They will catch up with that. And then the code is strict now, and engineers have also got enlightened about it. And we are conducting more and more conferences to give more and more knowledge on that. Thank you very much.
Yes, sir. Speaker, sir. Ramesh, sir.
Yeah, yes.
Sir, there are few questions in the chat box, sir. Can I go through quickly,
Please,
sir?
please.
Yes, sir. Can you please explain the length of fixity in file foundation design? Question asked by Subbarao.
Length of
Fixity, length of fixity in file foundation.
those things they have to refer the code. Okay.
Okay,
Here,
sir.
our main thing is not the design. That is a separate topic.
Yes, sir.
And any question regarding my presentation, I can answer.
Yes, sir. V.S. Chalpatrao garu posted, sir, an apt talk by the speaker, equally competent in theory and practice, which is needed for practicing engineers. Congratulations to the coordinators. He posted, sir.
Thank you.
And Vinod the Seklaker. Foundation in sandy soil. Which type of foundation you suggest? In sandy soils, what type of foundation you suggest? That is a question, sir.
See,
For residential apartments. For residential apartments.
see, before asking that question, I already told you the type of foundation depending on the load which is coming from the superstructure. That is one point. Then we will go for a shallow foundation or the deep foundation. If you are going for the shallow foundation, again, you have to design it. So shallow foundation may be a raft foundation also. If it is for the apartments, you have to go for the shallow foundation. Sand, whenever you are going for the machine foundation, you should be very careful when the sand is there. Sand, we are not going to suggest any foundation. See, sand, if it is confined, it acts like a rock. If it is punctured, strength will go. So many aspects are there. Okay, it is a separate topic actually. My point here in this lecture is the before going for any foundation design, one should go for soil investigation. If you are having any problem in facing the soil foundation, you can talk. So for example, sand. For sand, you have to go for static cone penetration test soil investigation. It is popularly known as Dutch cone test. So it is Holland. It is most of the sandy area. In the sandy area, you cannot do, the regular boring. So you may have to go for the DCPT test. So such type of questions I can answer for in this lecture. For other things, so it is also slightly out of my topic, but since the investigation, soil investigation in sand can be done using the SCPT test, static cone penetration test. The cone dimension is 10 centimeter area and its apex angle is 60 degrees. That is according to IS code. So this I can give any details about the investigation and the laboratory tests. Okay. Design and other things are the separate topic. Okay, thank you. Hello.
Yes, sir. Yes, sir. Srikanth channel already discussed, sir, his question. Any more questions from the participants?
They can
Sir,
ask.
please unmute, sir. Dr. TV Srinivas, please unmute.
Yes, I have unmuted.
Yeah.
My question is, soil investigation is done at different places. Is soil investigation required to be done at different times of the year? Because the soil condition can change due to the rainy season and dry season, other things. Is it required to do at different times of the year or different places is enough?
Different times in a year is not required, sir.
Yes.
Because you will conduct a laboratory test in the saturated condition.
Yes.
You will find out the test. But if it is a type of soil, if it is a black cotton soil, let us say, if you conduct the soil investigation in the summer season,
Yes.
you may get more strength.
Yes.
But in the winter season, it will get less strength.
Yes.
So when in the classification, you will come to know whether the test is required or not. When you classify the soil, you will come to know whether it is a black cotton soil or whether it is a non-expansive soil, etc. Depending on the condition, the geotechnical consultant will give the clarification. So always I would say soil investigation can be done by feeling with the soil. It cannot be decided across the table. You can only plan it. So once the investigation is done, if required, and the geotechnical consultant, depending on the site condition, he will suggest the further test to be done. Soil investigation is not just an academic reason. It is for the safety and economy. Okay, sir.
And my another question is, when we have basements done, one floor basement or two floor basements, we find invariably in many cases water during the rainy season, water enters inside. Is it defective from the structural point of view or structural construction point of view, or partly due to the investigation of the soil?
No. Actually, in the apartments and basements, what we suggest is the raft foundation and leak proofing and other things. Structural engineers will do.
Yes.
The walls, leak proofing and other things. Water should not enter into the basement. I'm also in the apartment. We have two basements.
Yes.
Structural engineers have taken care. The leak proofing. That is suggested by the structural engineers in the design.
Okay. Thank you.
Any questions, sir? Okay, sir. Before my vote of thanks, I request Center Chairman Balan Sundaragar to give concluding remarks.
Sir, Ashwath here, before your vote of thanks, I would like to compliment Patnam Center.
Welcome, sir.
Very dynamic and conducting a lot of programs. Congratulations, and please continue the same thing. And I thank the speaker, Dr. Ramesh, and I'm very happy to see Dr. Srinivas Murthy from Araville. He is a very passionate civil engineer. Very happy to have such stalwarts in this program. I just wanted to say hi to all of you. I have no questions. Thank you.
Thank you, sir. Kakinada Center is your pet center, sir. You inaugurated the center. Yes, sir. Thank you, sir. Thank you very much for
Thank you.
participating, sir.
Thank
Thank you very much, sir.
Nice to see you, Dr. Aswath.
Thank you, sir.
you. You are doing well. Conducting the programs excellently. As Ramesh was mentioning, structural engineers are only considered as civil engineers and geotech are not. It is long back. Now it is not so. All engineers are very important. In fact, recently I've attended the BIS review committee, sectional review committee, where there was a lot of discussions about involving all aspects of civil engineering in low-rise buildings as well as high-rise buildings. I think in the days to come, we need to take responsibility and involve ourselves in all the discussions and see that the construction industry practices the excellence. Yes, sir.
Thank you.
Thank you, sir. Thank you, Ramesh, sir, for your excellent lecture, sir. It is blended with practical aspects and theoretical aspects. It is very nice, sir. Our members are very fortunate to have your lecture, sir. And I thank C.A. Prasad Garu, Anjay Prasad Garu, for his deep involvement in the subject and for expressing his views. I thank you all for making this program very successful, sir. Thank you very much.
And also, I
I-
thank Kakinada chapter profusely with gratitude for having given me an opportunity to share few of the things since I'm an academician. If I missed out some points, please feel free to reach me and educate me. Let us work together as a team and for the economy and safety of the civil engineering structures. Thank you very much.
Thank you, sir. Thank you very much, sir, Dr. H.N. Ramesh Garu, for accepting our request and delivering your lecture on the importance of soil investigation and civil engineering construction and earthquake effects. Even your throat is in unsupporting condition, sir.
Yeah,
Thank you, sir, for sharing your valuable experience and expertise with us. My sincere thanks to our Center Chairman Badam Sundara Garu for his valuable time and support.
I'm expressing I'm telling my unpleasant truth. Since 2 days, I am not keeping well with my throat infection. Continuously, I was drinking hot water and talking. Sorry if I am not heard properly.
No,
Hope I was audible properly.
No, sir, you are very much audible.
Okay.
And yesterday night, our Durga Prasad told that you are suffering from heavy cough, sir.
I'm
Despite of
not
that,
at my best today. I am not at my best. Sorry for that.
despite of that, your involvement is highly appreciated, sir. Thank you very much, sir.
Yeah, thank you, sir.
yes, sir. Yes.
Thank you very much.
Thanks to all.
Your attitude and commitment by taking hot water, continuing and giving the lecture is a great attitude. Fantastic. This is a commitment we older generation have, and I
Yes,
look
sir.
forward to the younger generation to catch up like this. Thank you,
Yes,
Dr. Ramesh.
Thank you.
definitely.
Thank you, sir.
Thanks to all our SSA members for participating in this webinar and our headquarters team for supporting in arranging this WebEx link and all. Thanks to all our student participants and members of student chapter. Thanks to our member Sairam for his support in this webinar organization. Thank you all. Thank you.
Thank you very
Concluding the
much.
session.
Thank you, Aswath, sir.
Thank you.
Thank you. Thank you very much.
Thank you,
I thought
Ashwath.
we should meet separately.
ನಮ್ಮ ಅಶ್ವಥ್ ಬೆಂಗಳೂರು ಅಶ್ವಥ್ ಅಲ್ಲ
ಹೌದು.
Yes, sir. Yes, sir.
ಹಲೋ ಸರ್ ಹೌ ಆರ್ ಯು
I'm fine, sir. Take care and take full rest. Your throat will be all right. Nothing to worry.
Thank you.
Right, sir.
Thank you to all.
Thank you.
Thank you, sir. Thank you.